Okay, now, we can work this out. If you get 100% annual interest compounded n times annually, then just using the procedures that we've already developed for compound interest, you can determine that this is what you have. This is your principal function, okay? So we're not going to worry about how we get this. We're just going to look at this because there's something you need to see, all right? So this expression, 1 plus 1 over n to the mt, just giving you a little background, because really the whole point here is going to be to evaluate this for bigger and bigger values of n, okay? You would agree that by the laws of exponents, this is equal to 1 plus 1 over n to the n raised to the t. Because when you take a power and raise it to a power, you multiply the powers, right? Well, right there the powers are multiplied. Here they are as a power of a power, right? A power of a power. Okay?
Is it necessary to put them two parentheses right there?
Well, see, I gotta, there's not another real good way to express this. There's not a simpler way to express this.
Okay.
Okay? I gotta put the parentheses around here so that I'm raising this power to a power.
Okay.
Okay? Otherwise, it wouldn't be clear that I'm raising the power to a power. Okay, so whether you understand that or not, that's not the point now. We'll talk more about this in class because everybody needs to see this. But the one thing we're not going to talk much about in class, they're going to take your word for it. If they haven't already gone home and done it, then they're going to have to go home and do it, right? It's real easy with a calculator, okay? So what we want to do is we want to take this expression, just 1 plus 1 over n to the n. Okay? And evaluate 1 plus 1 over n for bigger and bigger values of n. Okay? So I'm going to make a table. N the expression for 1 plus 1 over n to the n, and the value that you get when you raise 1 plus 1 over n to the n. Okay? And we're going to just start off with n equal 1. Okay, if n is 1, then what is the expression for 1 plus 1 over n to the n?
2.
Yeah, it's 2, but we're going to write out the details of the expression, and then we'll write the value.
Sorry.
And you just said what the value is going to be, so you're a step ahead of us as always.
Sorry.
That's good.
No, not
Okay,
sorry.
but let's write it out step by step. The thing that I keep reminding many of you to do so you don't miss something in between, right?
Yeah.
You know, that was a good jump. You know, I make jumps in differential equations class all the time with integrals, integrations by parts, and I get a sign wrong or some stupid thing. And I, of course, naturally do that on purpose. My students will pay attention and catch me at it. Okay? Don't really do it on purpose, but I'm not that careful to avoid it. I skip a lot of steps, just mainly to show them what happens if you skip steps. Also to speed things up in case I do get it right. Okay, well, anyhow, don't skip steps. That's what I'm really saying. Okay? So you just substitute, it's 1 plus 1 over 1 to the 1, right? Okay? And then we can do one step of simplification. That's 2 to the 1. So what's the value of 2 to the 1? 2. Now write out the expression and its value for n equals 2.